All right, looks like we are live. So today we are going to continue what we started yesterday. Yesterday we wrote a small proof of concept, a POC, for Ngrok in Go from scratch. So we had a server that accepted incoming connection from the outside and forwarded to a local service. And now we are going to take that and make it a MVP. So one of the issues we had last time was it was a bit unstable. And while it was somewhat working, it was not working well. So we can just go back to where we were yesterday. Let's start the server right there. And now we're going to start the client. We have this IP, and now we can go to a different machine to go from the outside and see that it works, it doesn't work anymore. Basically, there's something wrong somewhere, and we are a bit unstable. So, what we're going to do, we are going to start by making it an actual product with Git init, and actually even better than that, we're going to go to GitHub, and we're going to create a new repository. And we're going to call it Ngrok, because why not? Ngrok in Go. Simple enough. We can even say that it's going to be in Go. We can put it an MIT license. Why not? And once we have this, we're going to clone this. All right. We're going to clone this. Oops, right there. Git remote add origin of this. Git pull. Oops. Branch data set upstream origin main. So dash b main. Branch doesn't exist. What? Okay, so well. Let's do it a bit more simple. We're just going to clone everything and take the Ngrok.git. Here. So .git ignore as well. And now we should have, we are missing the license too. All right, now we should be able to remove that Ngrok thingy. And now we have everything we need. If we do a git log, we should be able to see that. In G3, we should see that it is signed from the GitHub one. It is good. And now we're going to stage all that. So initial commit basic POC unstable. And we're going to push directly to main because we're alone right here in that project. And let's see, we are here. We should probably add a readme at some point, but we have our code. It is how it is, and we have some trace. So now, what do we do? We're going to try to see and understand why it was not stable. So one of the things that was a bit obvious from last time is that as we explored the various possibilities and like how to do things, we added a lot of garbage, and something that happens quite often in a project. You explore, you go to different direction, and then like when something is working, it is very important to take a step back and to say, okay, what did we do? Why it worked, why not? And to clean up and to avoid having like to build on top of garbage that was never meant to be there, that was just really exploration. So let's see what do we have. We did have an up closer that prevents the client from closing, so that is probably not something we really want to do, but maybe. because at the end of the day, we never actually want to terminate that tunnel, at least not from the HTTP side of things. So one of the very obvious things that I see here is that we are, instead of having the tunnel being a connection, we could move that client that we create every time. We can move that as in place of the connection. So that way we don't create the client every single time. And that way we can basically leverage the persistence and the keep alive of the HTTP library. So let's do that real quick. That definitely should help. We have that tunnel ID, so we are here. Now we have our connection. The connection is still the same. Everything is pretty much the same here, except that it is going to be given the client. So here is going to be that client. Somewhere we probably initialize this. Yep, right there. HTTP.client. And then what do we have? In here we don't have a connection anymore. We use a client here too. We can keep some debug, why not? And is that good enough? I'm not really sure. It still compiles, great. Then we can, well, we can already try that. I don't really think it's going to help too much because we had some issue on the client side too, but let's see. We curl once, it works. We curl twice, it works. It actually seems to have helped quite a lot, just that. But yeah, still hanging. And I suspect that is because of the client. And here we can see we have some attempt to close, so that is probably a good thing that we actually override it and prevent it. Let's see. Let's go to the client and see what we can do. In the client, yeah, we had the client was a bit of a mess. It was a bit messy, so I'm thinking we get rid of pretty much everything. Because here we have our connection. We're trying to do some manual tunneling and everything. Let's take a step back, and we can leverage something that is part of the standard library, that is http util.new new single host reverse proxy. And let's take a URL. A URL is going to be url.parse of our destination. That is going to be localhost, I believe it was in 8089. And that means that we are going to have a reverse proxy that is going to point to that. But now we need to be able to accept connection. So for that, we need an HTTP server. So in order to have a server, we very similar to what we did on the server side with the client. Now we do the same thing on this side with the server. So we are going to start a server and to override the connection to be able to take incoming requests from that tunnel instead of from an actual socket. I mean, an actual socket that it would automatically create. So the server is going to be very similar to the client. So, but this time it is the server, not server. What do we have in that server? We have a handler. Our handler is actually going to be our reverse proxy. Oop. Let's create a reverse proxy. What else do we have here that could be interesting? The address, well, we're going to override that. Not much. Not much, but then we'll look at the method. Yes. So we have that method serve and serve TLS. In our case, because we already established the tunnel, we are going to put that just as serve, and it expects a listener. So how do we convert a net.con into a listener? Do we have something in the con connection, in the con object, that would do something like this? Probably not. Not a big deal. Let's take a look. What is a listener? Come on, what is a listener? A listener is an interface with accept, close, and editor. And we have that accept that returns the connection. So we can fake that. rather easily. So we create a structure that is going to hold the connection that we have in that we dialed to, and now we are going to implement the interface. So we're going to have a func listener that is going to be the accept, and that is returned the net.con and an error, and we are going to return, of course, l.con, and there is no error. If we, the other ones should be straightforward enough. Addr, that return a net.addr, that's going to return l.con dot local or remote. That doesn't really matter. We don't really use that. It's just to and then listener close. And in this case, if someone wants to close, attempt to close. Let's make sure we have some logs to see if that happens. It should not happen, but it should be good. So here we're going to have an issue because accept it's supposed to be blocking. So like when we have a regular network flow, we first implement, we first call like the listen, first bind and listen, and the listen returns us to a socket which we can then accept on, and each unblock of result of the accept is going to be client connection. In this case, we don't do that. We fake it because we are actually like doing the other way around. We actually dial out and expect it to use it as a client connection. So in order to fake this, we're going to create to use a small channel. Actually, like before doing that, let's see what is going to be the result, and we should be able to understand very quickly. Accept. And once we have this, we are going to basically implement our accept. That is going to be, we are going to do that listener, listener, yep. For con, that is a connection, and we're going to pass that to our serve, and serve is going to block. And what does it do? Does it return an error? It does return an error. Let's make sure that we catch this. Serve, all right. And let's see, is that going to work or not? As you can see, we have an infinite loop, accept. Why is that? It's because the HTTPS server is actually expecting accept to block until there's a new connection, and because we directly return the connection that we have, it just keeps trying. So we are, in order to fix that, we will use a channel, because a channel is a very easy way to block things and to control when it blocks. Because because what we want to do is actually, like, the first time the server calls accept, we want to hand over the connection that we already established for it, and the next time we want to block, because we already established a tunnel. We know that there is going to be a single connection always, and the connection is always going to be the one from that tunnel. The one thing we could do that if it closes, then we could basically like unblock, so that it's fine. Like let's keep it simple for now. We can always improve later. So in order for that to happen, like again, the first time we don't want to block, but the next time we want to block, which means that we will want to have a buffer channel. So let's go here and like, let's allocate our channel. Why is the compression not working? Because I forgot to give it a name. Yep. All right. That is what we have, and we want to make it a buffer channel with the size of 1. And in order for it to not block the first time and to block the second time, basically we can do l.ch. We're going to send something to the channel, because it's buffered. The first time it's not going to block, and the second time it is going to block. But then, like, once we when we close, we can basically close the channel itself. The structure has a 0 size. It is fine. So now, the first time is going to hand over the actual connection, and the second time is going to block. And we should have something quite similar to what we're trying to do. it accepted once, it created the tunnel, and now we have a 502. Why is it that we have a 502? Let's see, maybe because I forgot to restart the server, maybe, or invalid destination port. That also makes sense because I made a typo in the port. Oops. Come on. Where is my reverse proxy? Yeah, it's 8089. That would explain why. So now it works. And it seems to be much better. And if we look at the code, it is also much simpler, much cleaner. We leverage the standard library. We just basically created a fake listener that is going to return the connection from the tunnel that we hijacked. And then it is going to be a regular reverse proxy locally to that. A minor improvement that we can do right now, right there. So we don't really use that context. Maybe we should. We probably should. Net.dialer. And there is going to be d.dial context. Okay. D.dial context of CTX. All right, we have that dial context, that reverse proxy. You probably should give it a context too. I'm not really sure we can, though. We can give it the base context from the listener. And it doesn't really matter anyway. It is a background context. Good. But yes, so a minor improvement that we can do is that right here, instead of going to localhost 8089, we can actually go to localhost plus os.arg of 1. And that should be much more efficient. Oops. All right, and let's see again. We do that, and we are in a 1 AE. And if we go to our backend, well, what we're going to start actually another one of those in 8088. And this time also, let's go back again to 8089 because I just restarted it. The container here is CB7. And if we try again and again, it should be always CB7. And if we are here and we say it 8088 this time, now it should be my different service. And it is 280. And of course, if we go back and come back to 8089, it should be the original one. Yep, CB18. That is working pretty well. Next up, remember that last time we actually hard-coded the server ID, just so that we don't need to copy paste it again and again and again. We can remove that. So let's take this and say that tunnel ID equal and this. So this time we're going to get an actual tunnel for every different tunnel for each. So so now we can do actually the two of them at the same time, which is things that we could not do before. So if we look at those ID up and we do our curl, we are in CB7, which is the first one, which is what we expected. And now on this one, we should be on the other one. And we are. How cool is that? All right, and now that we have all this, we can actually keep track of it. So let's look at what we changed. We created a listener with the dial context. We removed pretty much all of all the manual copy paste that we did before. We instead of keeping just the connection, now we actually keep the client. So we let Go do its thing. This is where we store it. This is where it was instantiated before and allocated. And now we can commit it, and we can say that fix and connection like MVP. Ready? I was saying that is quite usable, and we can push that. All right, and I guess that's going to be it for today. And one of the few things that we could be doing, we could set up a CI/CD to actually build and release the client side of things. We could actually try to deploy that server into Fargate or into any kind of a hosting provider. We could add some features to let the client specify its own URL, or at very least its own prefix. We could also put in place some kind of authentication. We can also something that could be useful would be to be able to have the client to display its ID, because right now we only have the ID in the server side, so not really not really great. But yeah, many things that could be done. But as a MVP, I would think that is pretty good. All right, that's going to be it for today.